welcome to another podcast, and this podcast is on digestion and enzymes. So all things digestion and enzymes will be covered over this next 10 minutes or so. Let me just focus that a little. There we go, lovely. So first of all, let's tackle enzymes. Enzymes. Definition. Enzymes, so a biological catalyst. Now you know from your chemistry, a catalyst speeds up reactions. So these things, enzymes, are going around your body just speeding up reactions that would take place normally, but far too slow for how quick we need the things. So that's what enzymes do. The most common way of looking at enzymes is something like this. So this is our enzyme, and this is the thing that we want to break down. Like this. Okay, and this is called a substrate. This will go into there, so now I'm going to draw it when it's in, and it will come out as something different. So let's say, for argument's sake, it comes out like this, and this is the product. This model, this whole hypothesis is called the lock and key. Lock and key, because you've got your lock and your key fitting in. And the point of calling that is if a substrate came along that had the shape like that, it would be the equivalent of trying to put the wrong key in the wrong door. It wouldn't work. This is how enzymes work. So substrates will go in and come out, go in and come out, but if something tried to go in that wasn't the right shape, it wouldn't work. So how can we make these enzymes go quicker, or when do they work their most optimum? This is most easily represented as a graph. If you have temperature along the bottom, and you have enzyme activity, so how quick are they working up the side, then the graph would look like this. And it works at its best, which we like to call optimum, at body temperature, of course, which is 37. Now, if you go beyond 37, so into the 40s and the 50s and the 60s, then you can see that enzyme activity gets less and less and less. This is because the enzyme will denature. And what that actually means is it will change shape. The active site will change shape. So this bit will just change shape. So the substrate can't fit in anymore, hence not work. Now this is also true of pH. pH optimum is pH 7. Anything either side, anything either side, the enzyme aren't going to work as well. When we're describing graphs though on this, remember to try to use the word optimum. As temperature increases, enzyme activity increases until it reaches optimum at 37, and then thereafter it begins to slow down. So that's enzyme. So now let's try and incorporate that into digestion. So here's my artist impression of the digestive system. Nose, shoulders, and it's not to scale whatsoever, but I don't care. Let's just do that. Awful. Absolutely awful, but we're going to go with it. So, digestion, you need to know the root of food, start to finish. Then you need to know what goes on at those different places. I know this is really bad, I apologise. But, there we go, okay, right. So, you've got the mouth. What does the mouth do? It chews food, but also, first enzyme of the day, it will release amylase and carbohydrates. which are the same thing really, but so let's just go with carbohydrates. We'll do what they do at the bottom here. Let's make a little table. So carbohydrates will break down, it breaks down starch into sugars, glucose. So that starts as soon as you put some food in your mouth, let's say a ham sandwich, the bread in your ham sandwich will start reacting upon straight away. Carbohydrates is there, as well as being chewed up. The esophagus, using muscles, pushes the food down. So it actively has to push the food down. It doesn't just fall through gravity. Right, next up is the stomach. Now in the stomach we have acid to kill bacteria. The food is churned. One enzyme present here, just the one, and that is protease. Let's add protease to our table. Protease, the second of 3 enzymes you need to know about, breaks down proteins into amino acids. Okay, let's continue our journey. Next, this here, small intestine. And this is actually where digestion takes place. So all the things that we want for our body gets absorbed into blood. So that's what digestion is, getting the food into our blood. This happens at the small intestine. So if the majority of the food is absorbed into the blood, then all 3 enzymes are released. So protease, lipase, and carbohydrates. All 3 are going here. So we can now add our third one, our last one, to the table. Lipase. Fats into fatty acids and glycerol. They 3 enzymes break down large into small, large into small. The large can't fit through into the blood. The small can. That's why we need these things, these enzymes, doing that for us. Okay, last part of the journey. Well, we also need to mention about the pancreas. It's here. All the enzymes are made here. Like an enzyme factory. And released into the small intestine. Last part of our journey. So we've got small intestine, stomach, esophagus, mouth. Is the large intestine. Large intestine. So all the food that we don't want has the water removed. So water is removed here. Then you end up with feces, a poo to you and me, without the water. So ultimately the feces comes out of the anus with no goodness whatsoever that our body deems not good enough, or we don't need it. And that is digestion, start to finish, and enzymes incorporated. Okay, so have a go at the exam questions, and then I'll show you how to answer those after you've had your go. Thank you.